Hi, welcome back to Tech Talk. I'm Paul McKee.
And I'm David Bialis.
Today we're going to talk about voltage drop testing. We're going to use voltage drop testing to diagnose a commonly found issue in the shop. We're here at the Product Support Center, and we're going to be working with this 4300. What I would like to remind you, for all of the viewers, is that this is an interactive discussion. If you have questions or comments, please fill out the Q&A section on the Teams
Video chat.
video chat. Thank you. Let's get started. David and I will be diagnosing a fairly common issue. As I mentioned before, we have a 4300 here. The customer complaint is dim headlights. We'll be using voltage drop testing to diagnose the cause of the concern. David, would you be kind enough to turn the headlights on for me? Well, I think we can confirm the customer complaint. Clearly, the left front headlight is a lot dimmer than the right front headlight. If it may not be obvious on the camera, we can go ahead and look at the floor down here. I've got a considerably brighter right front headlight than I do on the left front. So in order to get started with this diagnosis, what we're going to have to do is establish a baseline with our battery. We'll be needing a voltmeter, some pins to test these connections, and some extended voltmeter leads. The first order of business is to establish our battery voltage, if you'd be so kind. David is going to check the battery voltage at the battery posts, and what do we have, David?
13.42.
Okay, now that is with the headlights on, so the circuit is loaded. The next thing we're going to need to do is actually test our long leads. What we don't want to do is actually create an issue and have to chase it down based on some fault with our leads. So David's going to go ahead and switch out the leads for me, and we're going to retest the battery voltage with the long leads. And what do we got?
13.42.
Okay, essentially the same voltage, correct?
Yes, sir.
So we've taken any potential issue out of this with our leads. The next thing we're going to do, if you would hand me those, thank you very much. The next thing we're going to do is measure battery voltage directly at the headlight. So we'll keep our polarity right. And David, you're going to have to help me because I can't see the voltmeter while I'm doing this. Tell me when it looks like I've got a clean reading.
Still at 0. Bouncing around. I've got 4.55 volts.
Say it again.
4.55 volts.
Okay, though that represents a real problem. What should we have here?
Close to 13.
Well, we should have battery voltage,
Yeah.
or as you said, pretty close to it. This represents, so you can do the math, approximately an 8-volt drop somewhere in the system that we need to chase down. All right. So what I like to do first is check the positive side. I'm going to give this back to you, David, and we have to understand what we're chasing down here. The circuit in question on the positive side runs from the battery post through a series of wires, through a connector up to the power distribution here. From the power distribution, it goes into the ESC, or electronic system controller. Mm-hmm. The electronic system controller, it's outputted through the brown connector here. It runs through the harness, through a chassis connection. From the chassis connection, it runs down up to this hood connection here, to this hood connection here, and then ultimately to that headlamp connection there. So what we're going to do is measure from the battery all the way in the back to the headlamp connection here and see what we get.
Sounds good.
So far, so good? All right, let's give that a shot.
So now we're doing voltage drop. Does it matter if I should go to the positive or negative?
You're going to the positive lead.
Because we're testing.
And what should we see? If you're connected to the positive lead and I'm connected to the positive lead of the headlamp, what should we see in a perfect world on the meter?
In perfect world, battery voltage or zero.
Zero, because we're both on the same side of the circuit. We're both measuring on the positive side of the circuit. If there's no perceptive low, if there's no resistance between our leads, there's no voltage drop across that resistance. We should be close to zero. Now, are we going to be close to zero? The problem is with the positive side, you've got a series of connections. Each one of them represents a small potential resistance point. Plus, we're running through an output at the ESC. That's going to give us a little bit more resistance. So let's see what we got.
You are at 0.55 volts.
And typically on a positive side, we can expect to see about a half a volt drop. So we're pretty darn close to where we need to be. So does this side have the problem?
This side looks perfectly fine.
Let's check the ground side. I'm going to move my lead on over to the ground.
Me too. Should I move mine as well?
You should move yours as well. So I'm on the ground connection of the headlamp.
You're getting a reading 8.3 volts.
Well, 8.3 plus the initial 4 and change that we measured at the headlamp adds up to approximately battery voltage, right?
Correct.
So that makes sense.
Yeah.
So for the ground side, we're working from a ground post on the battery to the frame rail, through the chassis, up to a ground stud here. It's listed on the wiring diagram here. From the ground stud, we're working down to a ground adapter here. From the ground adapter here, we're coming up to the hood hinge connector and then up to the back of the headlamp. What should we see on the ground? Now, I mentioned that at a half a volt on the positive side is considered normal. But with the ground, you're working with the bulk of the metal in the frame rail and the cab itself. It's going to provide a path of much less resistance. So typically we should be seeing somewhere in the neighborhood of 1 to 2 tenths on the ground. What we're getting,
8.3.
That is a real problem. So how do we proceed from here?
Well, if we know that the problem is between this lead and that lead. And
both leads are on the ground side.
Right, so we're going to have to narrow it down.
Well, the easiest thing to do at this point would be to bring that test lead up to this ground stud. So let's take as much of the truck out of this equation as we can right off the bat. Go ahead. And what do we find?
8.3. So our problem is still between the leads, and then this is eliminated, so this part's good.
That's correct. We've eliminated the chassis and the frame rail, the battery connections, all the way back to the negative battery post. So the problem is still existing, but it exists between the ground stud here and the negative connection of the headlight here. So what's our next step? Let's look at the wiring diagram. We're coming from the ground stud. We've got a chassis connection here to the ground adapter here. Let's go ahead to the ground adapter because it's easier to get to right there. Let's see, you've got the alligator clip, I'll need that rope, thank you. And I'm going to try to get me out of the picture. Oh. Now, I'm looking at this and I'm starting to suspect an issue here. I see a problem. This wiring harness is kind of floating in the breeze and I see signs of abrasion. So we're probably on the right path, but let's confirm that. So we're between the headlamp connector on the ground side and the ground adapter on the ground side.
You got a voltage reading of 8.03, so you lost 0.3 of a volt. So
okay, but we still have an 8 volt drop-ish between our meter leads.
Yeah.
So we're narrowing this down. What should we do next?
Looking at the wiring diagram, we just went to the ground adapter.
We're at the ground adapter with one lead.
Now we gotta go to the next ground adapter.
Well, no, we could, but I have a feeling we're not going to find a problem there because as we noted when we started the process, one of the headlights is still bright.
Oh.
And we're measuring between here, this ground adapter, and here, I'm sorry, here and here. I'm going to get the right side, correct side. The left front headlamp at pin B and the ground adapter here. So let's narrow it down from here. We can either bring this lead up to the hood hinge connector, or we can bring this lead down to the hood hinge connector. Let's take this one and move it up to the hood hinge connector and see what we find. So I'm going to come to the chassis side of the hood hinge connector. And what do you got?
No reading.
0 or no? Oh, well.
0.
0. All right, let's go to the other side of it. That's one of the tricky parts about doing this. I'm in there.
Might be the top one, still getting 0.
Well, remember, we're on, both leads are on the ground side. Do you have anything?
0.
Okay. So that actually indicates a reading.
Oh.
We're measuring for voltage drop between here and here, and we're getting 0. Let's go back and confirm. I'm going to go back to the ground adapter.
Got 8 volts.
Got it?
8 volts.
So we're back to 8 volts. We know the connector at the headlamp is reading.
Okay.
So what did that tell us?
The previous 2 points where you tested should be good.
Exactly right. So we're pretty well narrowing this down. If I take this connector off here and I come to here, well, this time I'm going to go to the bottom side of it. Let's take the connector itself out of the equation.
Still 8 volts.
8 volts. At this point, I'm running out of places to test. If I take a moment and evaluate this, I have, do me a favor, turn the headlights off. If I take this connector apart, I can see fairly clean, tight connection. It's not likely the connector itself is the issue. If I take the top off of the ground adapter, using my superhuman fingernail strength, I can see, well, I can see potentially an issue, but I could see that that connector or that pin on that end of the ground adapter seems to be backing out a little bit. But as you can see, the connector itself is clean and tight. So while that might be an issue, I don't believe that's the issue we're looking for. And the reason I don't believe that's the issue we're looking for is because on closer inspection, as again, I can see abrasion. When I look closer and I peel back some of this harness, let me pull this lead out of here. Oh. I can see more abrasion and, oh, look at that. We do have a indication of some corrosion in the harness itself. Clearly this is an issue because somewhere along the line we lost a P-clamp or a zip tie and it's been floating around rubbing on that drag link. So what we've done in fairly short order is we've eliminated the entire truck using ground voltage drop technique. Measuring for voltage drop across one side of the circuit allowed us to eliminate first the entire positive side of the circuit. Then we eliminated the battery connections all the way up
to the ground stud.
To the ground stud on the bulkhead. Then we walked it forward to the ground adapter. From there, we can walk it back down to the hood hinge connector, and we've eliminated all the rest of the circuit except for approximately 1.5 to 2 feet of wire. Excuse me. At this point, what we would be doing simply is disconnect both ends of that connector. We'll pull that tape back, expose that wire, and find the actual problem. And again, I suspect the problem is going to be right there where we've got a little bit of green coming out of that harness. So this is how we do this. Questions? I see we have one question on the screen. Can we do a voltage drop test when the battery voltage is only at 11 volts? Do you think that's a good idea?
Just because it's an extra variable, I don't think you should. Normally, like if you already have the headlights on and your battery's getting low already with the headlights on, it's just going to keep dropping further, and you might end up just chasing your own tail.
Exactly, it's 100% correct. At 11 volts, what we know is the battery condition is not optimal. What we don't know is how bad is that battery? How stable is it at 11 volts? Good battery voltage is going to be 12.6 volts. So in this case, we've got a power charger on it to stabilize it. But if you try to do this at 11 volts and you turn the headlights on, the battery voltage may continue to drop as you're doing the test. That's going to give you skewed results. You may end up chasing your tail. Do we have any other questions? Why do we measure battery? Why do we measure from a battery all the way to the headlights? Okay, that's a good question. So again, when we do the test, once we've established battery voltage and the fact that there is a voltage drop across from the positive to the negative side here at the headlight, then we've got to isolate which side of the circuit has the actual problem. Optimum in an ideal world, if we measure from positive to positive all the way back to the battery, what we're going to do is eliminate that side of the circuit as a potential problem. We should see, as we talked about earlier, approximately what?
Battery voltage or 0?
0, but because it's a positive side and you're going to have components like fuses, connectors, wires extending all the way from the battery, which have some internal resistance, connectors which have some internal resistance, fuse connections. The fuse itself doesn't have internal resistance, but the connection does. Potentially switches. In this case, we've got an electronic system controller that's going to add some resistance to the circuit. We can see up to half a volt. In this case, we saw just a touch more. We're going to call that good. For the question, why do we do it on one side at a time? Because we have to isolate one side at a time, and the ideal voltage drop across the circuit would be as close to 0 as possible. What else do we have?
Guess the second one.
How do I know where to place my leads? This one's another very good question. And I've seen this on a number of occasions. If you look at the battery itself, if you were to come back here and touch the lug on the cable, are you actually measuring battery voltage?
Yes, but you have a little bit of extra resistance.
Exactly right. And if that cable itself, or the lug on the end of the cable, or possibly the connection underneath that nut, were the problem, you would be looking at a wrong voltage here. You have to go all the way to the battery stud.
Oh.
Okay.
Makes sense, because there's more resistance even at just that point.
Exactly right. There's been occasions where I've started with a problem, it probably wasn't a single headlight. If that were the issue, we would be looking at all of the lights are dim. We'd walk it backwards, only to find that the problem exists in the first inch of cable. I've seen that one before. And we have another question. How do you recommend testing for a voltage drop on a circuit where the component does not function at all? Yet voltage measurements with a DMM are good. Some very small current is flowing. That's a very good question. How do you recommend testing for a voltage drop on a circuit where the component does not function at all? I suppose I would need an example to clarify this question. But if the component doesn't function at all, let's use our headlight example here. If the headlight itself is burned out, let's say there was water in the bucket, we know clearly that this headlamp was failed. We've got a couple of options. We can substitute a load with a known good load, either another headlamp, replace the headlamp, or possibly use a test light as the load. We have to flow enough current through the circuit to get the voltage drop. If you simply disconnect the connector, all you're measuring is battery potential, not current flow. We need current flow to show the voltage drop across the circuit. And how are we doing? The very small current is flowing. No. I think we did this one.
Yep.
All right. Do you have any questions for me, David?
I guess it's just going to be a little time for me to understand, whether it's supposed to be a high voltage or zero, battery voltage or zero.
Well, let's walk through it again.
I guess that's just going to be with practice.
Absolutely right. But let's walk through it again. The first thing we need to do is what?
Know your battery voltage.
Know your battery voltage. Always work with a clean, good battery. If the battery voltage is low, either replace it or service it, charge it, what have you. Be careful though, because if you're using a battery charger, okay, we're using a smart charger which has got a stabilized voltage. But if you're using a conventional box charger, what's going to happen to that battery voltage as you're doing the test?
It's probably going to fluctuate.
It's going to continue to rise as you bring that battery voltage up. So we're using a smart charger which has got a very stabilized current to it. If you're using that box charger, you would have to do the battery charging first and then take off the surface charge. What's a surface charge?
Anything above 12.6?
It's basically current floating around in the liquid of the battery. And the easiest way to get rid of a surface charge is simply turn the headlights on, count to 60. Turn the headlights off, count to 60 again. At that point, your battery will be stabilized and you can use that battery for this test. Then what do we do?
Test your leads, make sure those are good.
Correct. Make sure that you test your leads. If you've got questionable leads, you're off to the races. You're going to chase your own tail because you've introduced a new problem. Verify that your leads are good before you begin the test. Then what do we do?
I'm gonna check going to the headlight, see what the voltage we have at the headlight.
Then we got to see the voltage drop across the load itself. Mm-hmm. This is essentially a long lead. The ground and the power for the truck are just an extension of the battery up to this point. Mm-hmm. And there we establish that we do indeed have a voltage drop. Mm-hmm. Then what do we do?
Gonna isolate first the positive side or the negative side. Actually, doesn't matter.
It doesn't matter.
Just test one of them.
I always go with the positive side first. It's just because I'm more likely to find an issue on the positive side than I am on the negative side, but that's a personal preference. Okay. So how do we test on the positive side?
You go from the positive post of the battery to the positive of the headlight.
Correct. And in an ideal perfect world, we would see what?
Yeah, this is where we get zero. This is the part where I always get confused, but like now that I'm talking it through, once I know positive to positive should be zero, negative to negative should be zero.
Correct. Correct. Now in the real world, not that ideal perfect world, mm-hmm. In the real world we do have slight voltage drops across all of the connections. The more connections, the more they're going to stack up. In reality, a half a volt on the positive side is considered normal. But on the negative side, we don't have nearly as many connections. Why?
Because we're going through the chassis, through the cab, and that's usually all solid steel.
Exactly right. You've got a lot of bulk here for the electrons to flow through that creates less resistance for them to flow. So we're going to see less total resistance on the negative side. Ideally, a tenth, 2/10 of a volt drop across the ground would be considered normal.
Yeah, not 8.
Not 8. 8's bad. 8 is absolutely bad. Mm-hmm. All right, so we've checked the positive side. We found roughly half a volt. We're going to kind of ignore that. We go to the negative side, and we found 8 volts from the battery post all the way to the headlamp connector. Mm-hmm. What's next?
Yeah, so this was negative and negative, going to 8 volts. So that's too much. So we got to do process of elimination. And easiest and biggest chunk to eliminate is leaving the battery and going directly to this ground stud here.
Exactly right. Oh, we have a, can you confirm the process? Step 1, battery, double check battery leads. Let me read this exactly. Can you confirm the process? Step 1, confirm battery voltage. Step 2, double check meter leads. Step 3, measure voltage across the headlamp or the load. Step 4, measure voltage B positive post to headlight positive, or the load. Step 5, measure voltage between B post and headlight no. Let's back up. So once you've actually measured across the load the first time and decided that there is a voltage drop across the load, we have to stay on one side of the circuit or the other. Do not go back across to the ground. If we go back across to the ground at any point, what are we measuring?
For the battery potential?
Battery potential, not voltage drop. And depending on where you measure it, we could potentially be reading some battery potential and some voltage drop. That'll confuse you greatly if you do that. Measure voltage between B post and headlight negative. Well, you've done that step to begin with. Step 6, depending on where the voltage drop is found, positive side or negative side, walk the leads back down the circuit in question to isolate the resistance.
Yeah,
go ahead.
This was actually right, yeah, because if you look, it says step 4, measure battery voltage between B plus post and headlight.
Oh, I see. I'm reading that wrong. It's B negative.
Nice.
Okay, I stand
Step
corrected.
5.
Measure voltage between B negative post and headlight negative. That is correct. Thank you for catching that.
Okay.
Step 6, depending on where voltage drop is found, positive or negative, walk the leads back down the circuit in question to isolate the resistance. Yes, okay, so the next question is, are we back probing these connections at the headlight? Yes, we are. We're using a very fine pin. The reason we're doing this, number one, we have to actually have.
Yeah, I don't know if you want to see it on here.
We actually have to have the load connected. If it is a delicate connection, we may want to use some sort of universal breakout to create that connection. In this case, we're working very carefully around the weather pack to make sure we're not hurting the leads or hurting the connections at the load. And I see that we have no more questions on the screen. So we've gone through voltage drop testing with a common issue you might find in the shop.
Yeah, I feel a lot more comfortable with it, just from talking it through, talking it out myself makes me a lot more comfortable with knowing what I'm doing. I could definitely do this by myself in the future.
Very good, very good. Well, we thank you for your time. As I said, measure one side at a time. Work your way from the battery back to the load until you find it. Remember, one side at a time. That is key. If we don't have any more questions, we hope you found this helpful, and we want to thank you for joining us. Have a good day.